These are the notes for H4-1. It's titled, How Can I Solve? Today we're going to look at strategies for solving equations. These are equations that we've practiced already this year. Some of them you may feel good about, some of them you may need some practice. But we've worked on general linear equations and we've just got one variable and nothing special happening. We've talked about quadratics. We've solved those in multiple ways this year. We've talked about solving radical equations. We just finished working on rational equations in the last chapter. Okay, so we're going to work on these plus others in this chapter. So let's go ahead here. And today is just a review and some practice on how to solve some of these. You may not solve them the exact same way that I solved them because there are multiple ways, but you may want to listen to some of the ways that I'm showing you how to do it just in case, because there are some ways that are a little bit more efficient. Let's get started. So the first one we see here, it says solve the following equations using your previous knowledge. Number one, we have the quantity of x plus 3 squared minus 5 is equal to 4. So there's typically two main ways that I've seen students solving this today. One is to take it here and we're going to simplify this side. Okay, so some of us have chosen to square the x plus 3, which we know is x squared, plus 6x plus 9, right? And we still have that minus 5 is equal to 4. Let's just go ahead and finish simplifying on the left side, right? Because we have that positive 9 and that negative 5. So when we combine those, we have x squared plus 6x. And now I think that becomes a plus 4 is equal to 4. And then since it's quadratic, we'd want to set it equal to 0. So we would subtract 4 from each side. And we end up with x squared plus 6x, right? And this would give us a 0. Those are both going to be 0 pairs. So this equals 0 right now. And then probably the easiest way I would say would be to factor out the greatest common factor, which would be x. So you have x times a quantity of x plus 6 is equal to 0. And then just use your zero product property. You get x equals 0. And x plus 6 equals 0, which would lead us to get x equals negative 6. Now, for checking purposes, if we plug both of these in, I'll tell you they both work just fine. But I want to talk real quick about a second method for solving this, because this second method can tend to be a little bit more efficient for some of us. Sometimes factoring isn't our strong suit, so I'm going to recopy that original problem. I have x plus 3 squared minus 5 is equal to 4, right? So on the first one there, we simplified and then got into factoring. For this one, we're going to solve it by undoing things. Our goal here would be to isolate the grouping symbols. Okay, so we want to isolate the grouping symbols. We want to get the x by itself, essentially, but when we look here, our x is inside these grouping symbols. So we want to get the quantity of x plus 3 squared by itself. So in order to do that, the first thing we're going to do, let's just go ahead and add our 5 to each side. So we're going to have the quantity of x plus 3 squared is going to equal 9. Now we need to undo the square. So to undo a square, we're going to take the square root. And this is the part where you have to make sure you're paying attention. When we take the square root of something squared, it leads us to have the absolute value of whatever was inside. And you can think of it as like, if I was squaring something, right, what could I square to get 9? Well, there's actually two values that we could have inside of here, right? 3 squared is 9 and negative 3 squared is 9. So this is just another approach to come up with the two values. So the absolute value of x plus 3 would have to equal 3, which tells us then that our x plus 3 is going to have to either equal positive 3 or our x plus 3 is going to have to equal negative 3. And you'll see some people will write it like this when they're doing it there. I'm just going to kind of read on the side, just a side note here, okay? Some people are taught when they take the square root, they'll have x plus 3 is equal to positive or negative 3. And that's the same thing I did. I just split it into two equations. And now we just finished solving, right? We're going to subtract the 3 from each side. And I end up here that x is equal to 0, which is the same thing you see as we got the first time we did it. And then again on the right side, we're going to subtract 3 from each side, and we would end up with x is equal to -6. Right? Both of them the same answers we got when we did it the other way. Okay, so both methods are acceptable. Sometimes one might be more efficient than the other. It's good to know both ways to do it. Let's move on. Our second set of problems, we have number 2 is the quantity of 3x minus 1 to the third power plus 2 is equal to 10. So for this one, let's kind of take that second approach like we did on the first problem where we just undid it backwards. The reason I want to do that, if I took this and I expanded it out, if I did 3x minus 1 times 3x minus 1 times 3x minus 1, I'm going to end up with a 27x to the third, right, problem there, and it could be like plus or minus something. It's going to be, a longer polynomial that we have to deal with, and I don't know that we're all completely ready for that. So let's try this by undoing it first. We're going to try to isolate the grouping symbols, right? So the grouping symbol that contains x is that quantity of 3x minus 1 to the third power. Let's get that by itself first. So we're going to subtract the 2 from each side. We've got 3x minus 1 to the third power is equal to 8. Now to undo that third power, we would take the cube root of each side. And the cube root of 3x minus 1 to the third, right? Remember, that's like saying the 3x minus 1 to the power over root, so it would be like 3 over 3, which is just 1. So this is just the same thing as 3x minus 1. You don't even have to put parentheses around it and make it like to the first power, right? Because we don't need that. It's just excessive. So the cube root of 8 is going to give us 2. And we don't have to worry about absolute value on this because there aren't two numbers that we can cube to get 8. Think about it. Something cubed gives us 8. Well, 2 cubed gives us 8. But if I tried to put in a -2, that would give us -8. So that's not going to work for us. Okay, so this one only has one answer when we do the cube root. And now we'll just finish solving. Add 1 and add 1. We get 3x is equal to 3. And so when we divide, we'll get x equals 1. For checking, you could just take it and plug it in, right? It's really easy to do. 3 times 1 minus 1, we're going to cube all of that and then add 2 to it, and it should equal 10. So this would be 3 minus 1 is 2. 2 cubed plus 2 is going to be 8 plus 2, which is 10, and we see that that still equals 10. For number 3, let's go ahead and solve that one. Let's look at doing it by, I've had people, simplify it, which is totally fine to do, and then factor it. I'm going to do it a little different. I'm going to do the undoing method there because I think this is the most efficient way. So remember, our goal here is to isolate these grouping symbols where x is. See how it's raised to that second power. So we're going to have to get rid of the 4 and the 5. Okay, so let's start out by getting rid of what's not attached. So that would be the 5. We're going to subtract it from each side. When we subtract 5 from each side, we now have 4 times quantity of 2x plus 5 squared is going to equal 64. Now to get rid of that 4, right, we're going to divide both sides by 4. And we're now looking at 2x plus 5. That quantity is squared, and that should equal 16. And now to undo the square, right, we're going to do the square root of each side. So we're going to say here this would be the absolute value of 2x plus 5 is equal to 4, which means that 2x plus 5 should equal positive or negative 4. And really that just means, right, two different things. 2x plus 5 equals 4, and 2x plus 5 is equal to negative 4. And then go ahead and finish solving. Subtract 5 from each side. We've got 2x is equal to, what is that, negative 1. Divide by 2. X is equal to negative 1/2. On the second equation, subtract our 5. And we've got 2x is equal to negative 9. And when we divide each side by 2, we're going to get x is equal to negative 9/2. Or if you want to write it as, x is equal to negative 4.5 or negative 4.5, that's fine too. Either of those would work. And for time's sake here, right, if you choose to go back and check these and plug them in for x, they will both make it true. So the answers are x equals negative 1/2 and x equals negative 9/2. Let's move on to number 4 and 5. Now these ones are radical equations, okay? So we can still solve them the same way by trying to isolate our grouping symbol that contains x. Okay, so in order to do that, right, we're going to have to get rid of the 2 on this first one. So it says 2 times the square root of 3x plus 8, and that equals 20. So since we're multiplying, right, we're going to divide both sides by 2 first. We have the square root of 3x plus 8. 20 divided by 2 is 10. Now to undo the square root, since the whole side, or the whole left side is being taken the square root of, we're going to square it. Now this is different than taking the square root of something that's being squared, right? When you think about it, there is the square root of something equals 10. There's not two numbers that we could have in here, right? So it's not like when we're saying something squared equals 10 and then we could get a positive or a negative. This one's just going to have one solution, right? We're just looking at one solution right now. Typically your radicals will end up with just the one solution. I can't say every one of them there because there are some that won't, but for the most part, okay, we're going to have, this would be a 3x plus 8. We don't need to square everything underneath, right, because this is canceling out the square root, and that equals 100. We'll subtract our 8 from each side, and we now have 3x is equal to 92. And then we'll divide each side by 3, and x is equal to 92/3. Now let's check that. A lot of people looked at this one today and not been sure if it's right or wrong. If I plug it in, 2 times the square root of 3 times 92/3 plus 8, does it equal 20? Well, this part here, right, if I multiply 92 by 3 and then divide it by 3, right, it's going to leave me with 92. So I have 2 times the square root of 92 plus 8, which is the same as saying 2 times the square root of 100, which is 2 times 10, which does give us 20. So we know that that is correct. So our answer for number 4 should have been 92/3. Let's look at number 5. Same kind of problem, except now we have 2 things happening on the outside, right? We have this times 3 and we have plus 9. So remember, just like the previous problem we had on the previous slide there, we want to get rid of what's not attached first. So I'm going to get rid of this 9. I'm going to subtract it from each side. We have 3 times the square root of 4x minus 8 is equal to 6. Now to get rid of this 3, we're going to divide by 3 on each side. We have the square root of 4x minus 8 is equal to 2. And then to undo the square root, we're going to square it. So we're left with 4x minus 8 is equal to 4. And then just finish solving it, right? Just take your time. Notice I show my steps. I show what I'm doing to each side to keep it balanced because I see a lot of people make mistakes just because they refuse to write things down. You do you, but some people are mistake prone when they try to do that. Like, look what I did. I changed what I was saying there, and then I just made a boo-boo there. I started dividing by 3, right? It's really easy to do that, to make a mistake like that. So if I hadn't written that, I wouldn't have caught that. That wasn't even intentional. So x is equal to 3. Plug it in to check it. 3 times 4 is 12. Minus 8 is 4. The square root of 4 is 2. Times 3 is 6. Plus 9 is 15. I know it works, and I can feel good about it. All right, at any point here, remember you can pause the video, work it out yourself, and then check to see if you're right. I'm going to look at number 6, which is 2y minus 3 times y minus 2 is equal to negative 12y plus 18. So for this one, I'm going to look at it here, right? We've got y's in both of these parentheses over here, so I'm going to simplify this side just by multiplying this out. I'm going to FOIL it. All right, so I'd have 2y times y would be 2y squared. 2y times negative 2 is negative 4y. Negative 3 times y. And then negative 3 times negative 2 would be plus 6. We combine those together. We're looking at 2y squared minus 7y plus 6 is equal to negative 12y plus 18. So since it's quadratic, it's got to equal 0. So we'll move things around so that we can get it that way. So I'm moving my right side over to the left side. We have 2y squared plus, what would that be, 5y minus 12 is equal to 0. And then I've seen people use quadratic formula here, but you can also just factor. In this case, let's see, we'd have a 2y and a y. Let's see, I subtracted 18, so that's a negative 12. So let's see, I have 4 times 2 is 8, and then 3. So I need a positive 4 and a negative 3. So 2y minus 3 and y plus 4. Use your zero product property. And you're going to get y is equal to 3 halves, or that's the same thing as 1.5 if you want. And we also get y is equal to negative 4. For time's sake, I'm going to tell you that they both work. I've plugged them back in to make sure of that already, but if you need to do it, you can go ahead and do that. Let's move on to number 7. 7 has multiple ways this one can be done. I think the most popular way I've seen today is just by simplifying this side. So let's see here. X plus 2 squared, right, would be x squared plus 4x plus 4. And then let's distribute this positive 4 through. So we have plus 4x plus 8. We still have our minus 5 is equal to 0. When we go to combine our like terms, x squared is all by itself, but I've got a positive 4x and another positive 4x, so that should give us 8x's. And then 4 plus 8 is 12, minus 5 should be 7. And now we can go ahead and just factor this. X, we have x plus 7 and 1, and then just use your zero product property. You'll get x is equal to negative 7 and x is equal to negative 1. Again, I've already checked it here. I don't want you to have to watch me check it. Especially on this one, I'll just show you another quick method there in case you're interested. We could also use a little bit of U substitution. Call this U substitution. And this is where we see something that might follow another pattern, right? Where we've got our x plus 2 squared plus 4 times x plus 2 minus 5 is equal to 0. We notice that we have this x plus 2 here, and we have it here. On the left one, it's being squared, and on the right one, it's to the first power. So this can follow a quadratic pattern, right? We can substitute something in for the x plus 2. In this case, right, this is why we call it U substitution. Let's just let U equal x plus 2. So that means wherever I see this x plus 2, I'm going to substitute in u. This becomes u squared plus 4 times u minus 5 is equal to 0. And now we can factor this, right? We can look at this as, this is an easy one. We've got u plus 5 and u minus 1 equals 0. Use your zero product property. You'll get u is equal to negative 5 and u is equal to positive 1. But we're not solving for u, remember, we're solving for x. So where we see this u, if we know that u is really the same thing as x plus 2, let's put x plus 2 back in for our u. So we have x plus 2 equals negative 5, and x plus 2 is equal to 1. Now when we finish solving, you'll see we get the exact same answer. X equals negative 7, and x equals negative 1. Okay, so just another method there that you can use. This was something we wanted to teach a little bit earlier in Chapter 3, but we didn't have time this year. But I'm still going to show it to you anyway. There'll be some uses for it maybe later in the year. All right, so just a couple more here. I think 3 more. So these ones hopefully will be a little easier now that we've talked about this already. But when we look at 8, we have the absolute value of 5x plus 2 equals 12. Right? And when we look at it here, right, our absolute value brackets are already by themselves, right? And we have the stuff that's left in between. So when you think about it, the absolute value of something is equal to 12. The only numbers that would make that work would be 12 or negative 12. Those are the only two numbers that are 12 units from 0. So what we're thinking about here is, right, this expression 5x plus 2, right, 5x plus 2 has to either equal 12 or 5x plus 2 would have to equal negative 12, because those are the only two values that we can end up with in here. So we split it into two equations, right, and then we just go ahead and solve them, right? Subtract 2, we get 5x is equal to 10. Divide by 2, we'll get x equals 2. Oops, x equals 2. And then we do it on the other side there, when we subtract 2, we're going to get 5x is equal to negative 14. And then we divide each side by 5, we're going to get x is equal to negative 14 fifths. Or that's what? That's about negative 2.8. So when we plot these on the number line here, right, I'm going to go ahead and put my negative 14 fifths on the left. I'm going to put my positive 2 on the right. And we just need to make sure that we have closed circles there, because those are the solutions. Now for number 9, right, again, it's an absolute value equation. We've got our absolute value brackets, something inside, but we need to get rid of what's not attached. So since we have 4 times the absolute value of 8x minus 2 equals 8, we want to get rid of this 4 first. So we're going to divide both sides of the equation by 4. And we have the absolute value of 8x minus 2 is equal to 2. Now, just like the last one, when you think about what two numbers are 2 units from 0, right, we know that this value could be a 2 or it could be a negative 2 to make this true, which means that 8x minus 2 has to either equal 2 or 8x minus 2 has to equal negative 2. And then we're just going to solve those. So we get 8x is equal to 4. Divide each side by 8. We get x is equal to 1/2. On the other side, we'll add the 2 to each side. And we now have 8x is equal to 0. And then when we divide each side by 8, right, we know that x would equal 0. So our two solutions here would be 0 and 1/2. And please write them in order from least to greatest on the number line. We'll try to do that. And there's our points. So hopefully we understand how to plot these points on here. This will hopefully transition us into doing absolute value inequalities later and making it easier for us. All right, last problem is number 10. We have the absolute value of 3 minus 7x is equal to negative 6. Okay, and all day long I've had people go through and solve this, but then realize when they plug their answers in, they don't work. And the main reason why here is this, right? Our absolute value is already by itself. So when you think about it, absolute value of something is equal to negative 6. Well, what's wrong with this statement? Because I can't put 6 in there because that's not true, right? And if I tried to put negative 6 in there, the absolute value of negative 6 is also positive 6, which doesn't work either. So hopefully many of us remember here that absolute value cannot equal negative numbers. It's always going to equal 0 or positive numbers, right? So, and therefore, in this case, since it can't equal negative 6, then we have no solutions. And we'll just put an empty set up there on the graph. So that's no solutions. All right, that's all I got for you. These are just some updated notes so that if you need to view them, you're welcome to do that. This is chapter H4-1, just a review on solving equations. If you have questions,